Hi. Good evening, everyone. My name's Phongsatorn from Mongkut University of Technology, North Bangkok, Thailand, or KMUTNB. So today, I would like to introduce our satellite that will go with JCube program this year. Um, so I myself actually we have launched KNACKSAT-1. It's 1U CubeSat with Falcon 9 rocket 7 years ago. And after that, we realized that even a CubeSat to even 1U CubeSat, it's very hard for um, university in our country or even organization in Thailand that can afford the price for launching a whole satellite to into the orbit. So we come up with a Rideshare mission um, that we designed um, our satellite to be a multi-payload concept. So then we can share um, a lot of payload inside uh, the CubeSat, and we can share the launch cost. So that's the main concept of our satellite. So that's why 4 years ago we applied for JQ program to support us not for the launch, not only for the launch, but also support us how to uh, design uh, a CubeSat. So we actually inside the satellite we only have 1U space for bus system, and then we have um, 2U space for um, up to 10 payload inside. Actually, the idea is not a new idea to share space inside the satellite and launch into space. Um, in Thailand, I don't know many of country um, have the same transportation like this. We call Songtel in Thailand. So it's very cheap. Everyone can afford to go to the same destination. So we we want everybody or how to say many organization or many university, many school in our country can afford the ticket to access to space. So after we announced for ride sharing partners in Thailand, many organizations apply for our satellite to go together into space. So we have payloads from pre-engineering school. It's a high school student team, and we also have a group of researcher of a real system in Thailand. So I will show you some of very interesting um, mission of our satellite and other organization like NARIT, National Astronomical Research Institute of Thailand. So we have research institute and oversee our neighborhood country, our neighbors like Malaysia and Philippines also participate in this satellite. So and the last we also have a big telecom um, company in Thailand, AIS. It's so they also have their own payload. They want to test IoT payload for the future service. So we totally we have 7 partners inside our KNACKSAT-2, and it's going to be launched in within this year. So for collaborations with Japan University, actually we are a three-party collaborative partners. So I am from KMUTNB, and the INSTEAD is an uh, space organization inside the university, and we also have our spin-off. Actually, the student they graduate from KMUTNB also QTech alumni, so they start company inside the university and officially um, supported by university called NB Space. NB is it's not Nihonbashi, it's North Bangkok. So it's they rent a small room in our building, and they start to build CubeSat components and CubeSat satellite parts. So they fabricate and verify and do some kind of documents for university, and then we will bring our satellite to QTech and learn how to to do the document about the safety review. It's very different from safety reviews we doing with rocket company in the past. So it's a more strict and it's more detailed. So we have learned a lot. So in that way, QTech staff kindly teach us a lot how to design to uh, to pass the safety review, and also we not only myself. It's our some of Thai students, they are studying in QTech, and they can help us testing our satellite, so they can learn how uh, to do the environment testing too. So tomorrow I will go to Japan now. I'm in Bangkok, and um I will bring the KNACKSAT-2 to JAXA on 25. So this is the technical information about our satellite. It's a in here. So we want to introduce that it's quite different from other CubeSat in the past, or most of CubeSat in Japan. We use the data protocol CSP. It's widely used in I think it's widely used in Europe before. So it's very convenient. So we have uh, many reasons to adopt CSP to communicate to how to say communicate with um, our payload owners. So this is a picture that we test our satellite at QTech many years ago, and after that we uh, we take a photo with Professor Joe. And this picture is uh, last over more than 1 year ago. We have actually we finished our satellite 2 years ago, but it's it's a delay for from Thailand side that to uh, to issue the license for our satellite. So in Japan, or in your country, it might be more faster than us. So it takes more than 1.5 year for us to acquire a license. So that's why we have to wait a long time. So now we finish the licensings for RF, API-A, and API-B already. So now we are ready for launch. So so the mission I pick up here is I want you to see that the there are two IoT payload developed by private company called AAS in Thailand. They put an store and forward payload, IoT payload, and a gateway into the satellite. So they want to test it in space, and this is the a kind of the system they developed it. So this is the gateway used the Raspberry Pi, and this is store and forward. It's very simple. Just get the data and forward it to the ground station. This is the payload developed it and delivered to us. So they name it Postman for the store and forward because receive the message and forward the message. And they also have their original Chef payload gateway. So they can modify and upload the original software or firmware to CSP connected to the satellite, and then they can do some um, specific experiment on orbit. And this is the concept. So all of the partners they will connect it through our cloud server located in university, and they can how to say, they don't worry to how to say to about operating the satellite. So when the satellite come over um, our ground station of a university, they can directly communicate it with the satellite through the network from their organization. So it's a network design for the system. It's more that's why we um, adopt a CSP protocol for communicating with payload and other components. And another mission is APRS. The APRS is itself, it's not very new, and I think everybody also have the same uh, APRS mission like this, but the user of our APRS system, it's the rail system in Thailand. So it's very funny that um, most of the local line is not electrical vehicle, it's a diesel power rail system. So they have uh, no system to detect that where the train is. So we help them to tracking the train around the countries. So we also developed it the the module to install into uh, the um, into the train driver's room. So it will look like this. I would like to show you this. So it's very old. It's I think it's over 100 years old train, diesel train that I believe that uh, we we got this train from Japan over hundreds years ago. So in this picture is it's maybe the new one, but it's not new at all. So that it's very low tech and no technology for tracking the train. So we put our module to to the driver's room. So when in the northern part of Thailand, there's a lot of high mountain, so there's no um, uh, mobile signal. They can they cannot communicate it to via the mobile. So that's why we want to put API system here so they can send the information of the position and velocity of the train through the satellite, and then broadcast back to the ground station. So the command center in Bangkok, they can capture that what's happened with the train. So our user is a Rail System Research Group of Thailand. So it would be look like this for the idea. And in the future, if it proved effective, we believe that we can build a lot of mini satellite for a specific purpose for this kind of users in Thailand. So yeah, actually we have from the north to the southern part of Thailand, we have 5 routes. So all the routes we will set our gateway and portable ground station to track the train. So that's all about our satellite KNACKSAT-2. Thank you.